All right, so now that we've reviewed GCF, let's move on to some other quadratics that we cannot use GCF or solely GCF to solve. So I'm going to put a line down the middle because usually we use factoring by grouping, but I want us to review both. So here, a is 1. Remember, quadratics are in the form ax squared plus bx plus c. So if I had to identify my a value here, my a value would be 1. So hopefully we all see that. So when a is 1, I can just look at my constant c. I can just look at that and say, what are the factors of c that I can add or subtract to give me b? Well, I know the factors of c are 1 times 24, 2 times 12, 3 times 4. What did I say? 3 times 4, I'm sorry. 3 times 8, 4 times 6, all right, and that's it. So then when I'm looking at these, I determine, oh, okay, 3 and 8 has to be the numbers that I use because 3 plus 8 gives me 11. So when I factor this, I know it's going to factor into two binomials, and my x squared is going to break up into two x's. So there's going to be an x here and an x here. So in these two spots, I just need to put my numbers, 3 and 8. And in this case, I need a positive 24, but a negative 11. So that means both of them are going to be negative because a negative plus a negative is going to give me a negative 11, but a negative times a negative will give me a positive 24. All right, and that's it. So that's why it might be a little easier to use this method when a is equal to 1. What we have previously done is factoring by grouping. So if you like factoring by grouping, that is fine with me because we like to use it when a is not equal to 1. And so just sticking with one method, that's great. So when we do factor by grouping, we always do our a times our c first. So we would need to identify what a and c were. Well, we already said that 1 is a and that c is 24, our constant. So same thing, we end up looking for the factors of 24, and we just said we know that those factors are 3 and 8. But with grouping, I'm going to bring down my leading term, x squared. I'm going to split the b term into negative 3x and negative 8x, and then my constant comes down, plus 24. 20, and this is an 8. Don't know why I look so crappy, sorry. And now this is when I want to actually say, okay, well, what's the greatest common factor here? Well, if I'm looking at x squared minus 3x, the greatest common factor is x. So if I factor that out, I'm then left with x minus 3. And then I'm looking over here and I say, well, what's the greatest common factor between negative 8x plus 24? Well, I would again say that 8 is the greatest common factor, and I would again get x and 3 in here. But if I only factor out 8, I get a negative x here and a positive 3 here. I need a positive x and a negative 3. So that's why I'm going to factor out the negative. So we always want to factor out the negative, okay, if it's on our leading, which over here technically it is because we're grouping. Okay, so now that I see, So now that I see that these two are the same, they are essentially a greatest common factor. So I can factor that out, x minus 3. And I'm left with x minus 8. And we see that that's the same thing, and that's the factoring by grouping method.